Okay, so welcome back to another video. Here we have a nice little limit that we're dealing with, and then everything is in terms of like the sequence of constants. So what we're dealing with is the limit as t approaches infinity of a sub 1 to 1 to the power t plus a sub 2 to the power 1 sub t plus a sub 3 to the power 1 over t, and then all the way so on and so forth to a sub n to the power 1 over t divided by n to the power nt. And of course, all these sequence of those numbers of a, they are of course going to be strictly greater than 0. So I see this as more as like it's a basic, exercise for learning how to apply like, L'Hopital's limit, because that is what we're going to actually do here. And then there are some things that, of course, we're going to actually apply the continuity utilizing the natural log, function. So we first assume that the continuity does exist, and we can first apply that. We apply the natural log on both sides, find some simplification to the limit. And then if we actually come across, a dead end, then of course that's something that L'Hopital can, fix. So if we can actually get that out of the way and, utilize that, then surely we can actually come to some sort of, closed form of the given. So with that being out of the way and discussing, why don't I just jump right in? I'll call this capital L, assuming that the continuity exists. And with that the case, let's take the natural log of both sides. So I have the natural log of L is then going to be equal to, so first thing is that if I take the natural log, so that means I have the n and t go outside, but also that the n goes outside of the limit symbol since it doesn't affect anything with what's being taken the limit of. So I have n times the limit as t approaches infinity of then t, then multiplied by the natural log of everything here. So a sub 1, 1 to the power t plus a sub 2, 1 to the power 1 to the power 1 divided by t, all the way so on to a sub n to the power 1 divided by t, and then all this being divided by n. So continuing forward is then we can actually, of course, apply the natural law property. So this is division, so that means we have to do this as in terms of subtraction. So n times the limit as t approaches infinity, then t multiplied by, then the natural log of, so a sub 1 to the power 1 over t plus a sub 2 to the power 1 over t, and then add this all the way up to a sub n to the power 1 over t. Close that off, and then there's the natural log, and then there's the n, so then minus the natural log of n. Okay, then we just keep going forward with that. And then the next thing I can do here, of course, is that the t can go back inside, but I want to actually convert this in terms of like a rational function. So I'm actually going to write the t as a 1 divided by t under the denominator of the limit that we're taking. So the limit t approaches infinity, then everything. So the natural log of a sub 1, 1 over t, plus a sub 2, 1 over t, all the way up to a sub n, and then 1 divided by t. Then subtract the natural log of n, and then all this being divided by 1 divided by t. Give myself a big space, hold on. So then our next step here is that we're actually going to do a little bit of a change of variables over here for our limits. So we're going to we'll call this constant u. So we're going to let u be the, we're going to let u be the 1 over t, so we should be writing this in the opposite direction. So if that's the case, then that means that u is actually supposed to approach 0. Actually, I did write this correct technically. So with that being the case, and then I have an n, so I'll just divide the n outside. So I have 1 divided by n, and then the natural log of L, so then equal to, then it's the limit, so u approaches 0. And so everything is going to be the natural log of, so a sub 1 to the power u plus a sub 2 to the power u, all the way up to a sub n to the power u, and then close that off with minus the natural log of n, and then divided by u. Okay, and so what you'll notice is that this is actually just going to be in a form of a 0 over 0 indeterminate form when you plug the limit as u approaches 0. As you can tell, that for over here is going to be 1, 1, and then here is going to be 1. So it's going to 1's going to approach. You're adding n times 1 amount, so it's going to be ln of n, and then minus ln of n, so it's 0. And then the bottom, of course, is still going to be 0. So we have a 0 over 0 indeterminate form. So if that being the case, let's apply L'Hopital's rule. So 1 divided by n, and then natural log of L. So just keep that consistency. So we actually take of course, the derivative of both our numerator and denominator. So u approaches 0. So that means our numerator on the top is then going to be, so I think it's worth noting that u is just going to be just 1, so we can just disregard that. So really, in terms of what's on the numerator is that we're actually going to take the derivative of. So first thing, natural log of a sub 1 versus u, all the way up, so on and so forth. So that means if you take that derivative, so it's basically 1 divided by whatever's in the inside, and then multiply with the derivative of what's in the inside of our natural log function. So after all this, so we have a to the power, or a sub 1 to the power u, and then times the natural log of a sub 1 plus a sub 2 to the power u, natural log a sub 2, all the way up to a sub n to the power u of the natural log of a to the power n, or a sub n, and then all this being divided by a sub 1 to the u plus a sub 2 to the u plus all the way up to a sub n to the power u, and then close that off. And then as you take that limit again, so that means if you take everything approaches 0, so that means a sub 0, and then all that's just going to be just 1, so then it's just going to be the natural log of a sub 1, natural log of a sub 2, all the way up to the natural log of a sub n, and then all the way on the top, or the denominator, if you plug 0, so it's going to be 1 plus 1 plus 1 all the way up n times, so it's just going to be n. Then simplify things further, that you take the natural log property, since everything is a sum, so they can be turned into a product. So the natural log of a sub 1 times a sub 2 times a sub 3, all the way up to a sub n, and then divided by n. Okay, so multiply the n to both sides, that get rid of itself, so then the natural log of L is then just the natural log of a sub 1 times a sub 2 all the way up to a sub n, then take the e base both sides, we get that L, aka the limit that we're calculating, is going to be just the products of those numbers, a sub 1, a sub 2, a sub 3, all the way up to a sub n. So with that, that is our nice little closed form, the final answer to our limit that we're being asked to find that, such closed form. Everything kind of looks crazy from, because it's, sequence of numbers that we're dealing with, so it might get a little crazy from that. So, but we actually just figure out everything, that we take it step by step carefully, and then take the necessary precautions of using L'Hopital's rule. So let me just write that. L'Hopital's rule, just utilize that. Then we get everything here to simply just lead to the simplification of this product of those sequence of numbers. So yeah, that's pretty cool if you ask me.